This video is going to take you through a review of the Unit 2 test, and I am going to ask that you watch this review and compare it with your Unit 2 test before attempting to take the retake of the Unit 2 test. It's important to know what you got wrong and to hear an explanation of what should have been done instead of what you did do. That's the very least you should do before you try to take a test again. So I don't think this will take too long. Numbers 1 through 3 match the form with the vocabulary word that goes with it. This is just material that you need to know. So this goes back to that vocabulary. If you do not know the words that we're using, then it's going to hinder your ability to read directions and follow directions, which is obviously going to hinder you getting questions right. So you just need to know this. Standard form is ax squared plus bx plus c. Vertex form is that a times x minus h all squared plus k, and then factored form is a and then x minus p times x minus q. Now that might make a little bit more sense now than it did a couple weeks ago when you took the test, because we have spent the last several class periods factoring, and you might be able to recognize now that that is what factors look like. You have maybe the GCF, and then you have the dimensions of the rectangle. So that I hope makes more sense. But those are just vocabulary words that you need to know. You need to know which form is which. And there's no shortcut other than you make a flashcard and study it and make sure that you know what those words mean. For numbers 4 and 5, state the transformations on the quadratic and then sketch the graph. So there are two things that you were being asked to do. You can see the word "and" right there. You need to state the transformations and then generate the sketch. A lot of you lost points because you only did one or the other. Always read the directions. Stating the transformations, you remember that transformations are changes to the graph. So when we say state the transformations, what we're referring to are flip, left, up, down, right, whatever the transformations are. It got stretched, it got compressed, okay? And you need to state what those are. In this first one, we know that this is going to go left 4. Most common incorrect answer is right 4. And that, again, comes with practice. That left and right is backwards from what you think. I, at one point, posted a video that just went over the left and the right, and you can find that video linked on Teams. It just explains that one little piece of how the graph moves when you are adding and subtracting inside the function. And then to sketch it, I think I can do that better with the mouse. We go left, 1, 2, 3, 4. And remember that it is a parabola. So something like that would get you full credit. For number 5, we have the negative right there. That is going to reflect the graph over the x-axis. Sometimes we'll call this a flip. The minus 3 means it's going to go to the right 3, and then plus 2 means it goes up 2. So we go right 1, 2, 3, up 2. And then this one is reflected, so it's going to be flipped over. Okay, and that is full credit. Full credit answers on both 4 and 5. That was all you needed to do. Quick sketch. You want to show that you know the shape and the location and the orientation, and then you can look at the functions and interpret what that means for the graph. Okay, number 6 is review material. So this comes from Unit 1, and I did put on your study guide that you were going to need to know some review material. So this one says, write the function g of x that would take f of x and translate it left 3 if f of x is, what do we have? 3 times the absolute value of x minus 2 plus 1. Show all work or explain your reasoning. So I'm leaving the door open there for how you want to convey how you're arriving at your answer. The way that we did it in class looked like this. If you want to make a graph go left, you add 3 on the inside. And so the way this would look algebraically, it's supposed to be a G, is we would have 3, and then inside we'd have x plus 3, and then the minus 2. So basically you're just doing you're replacing the x with the x plus 3. So where you had the x before, it was just x minus 2. Now it's x plus 3, 3 minus 2. And then you would just simplify that. So if you have 3 minus 2, that would be a positive 1. Okay, and so that's about a 3-line problem. Now, I did accept other ways of explaining your reasoning. So if you wanted to say something like this would also work. F of x maybe goes right to. Okay, so maybe you recognize that the current function goes right to. So after going left 3, okay, I know that got super messy and I apologize. Hopefully you're listening to the video and not just watching it. That says left 3, okay? After going left 3, it will be 1 left of the origin. So what would it take to make it go left 1 from the origin? Well, that would be adding a 1. Okay, and so you can reason this. I want you to do things the way that makes sense to you, and not be locked into this is the only right way to show this. If you can show that you understand how to move the graphs left and right, and you can apply those transformations, I don't really care how you do it. Somebody else might do something like this, where they graph the original. The original goes right 2 and up 1. And then they might draw the arrow and say, okay, 1, 2, like 1, 2, 3 to the left is going to put it right there. And so if it goes 1 left and up 1, you would end up with like the 1 left up 1. So there's a lot of ways that you can show me that you understand how to take a function and move it on the coordinate plane. Just show me whatever is going to make sense to you and whatever means is going to convey that to me. Question 7. If f of x is negative x plus 1 all squared plus 4, state each of the following. You may sketch a graph, but you do not have to. I'm a very concrete learner. I'm very, very visual. So I need to see stuff. If you're going to ask me to state the vertex from that, I can do it without graphing it. But if I'm taking a test and I want to be super sure that I'm getting it right, I am absolutely going to sketch a graph. So that one is flipped, okay? I know you guys can't see what I'm pointing at. Hang on. I know that it is flipped over because of the minus sign. It goes left 1 and up 4. So you'll notice how often we do those transformations. Those transformations are really important. You can't just not know them. If you kind of put off knowing them, like maybe they'll go away, and they're not going to go away. So left 1, up 4 puts me right there, and it was flipped over. Okay, now that I can see it, now more of this makes sense. So the vertex is the highest or lowest point. That's going to be -1, 4. The axis of symmetry is the vertical line running right down the center, and it needs to start with an x equals, and that x is equal to -1. And a maximum value is the y coordinate. It's the highest or lowest point that the parabola reaches, and in this case, the highest that it reaches is y is equal to 4. Okay, do not try to memorize some pattern like I'll find the vertex and then I do the x and then I do the y. Think about what it is you're trying to find. Okay, you always want to bring this back to the context. What does AOS stand for? That's axis of symmetry. What is min-max? Min-max is the highest or lowest point on your parabola, because if somebody like tweaks the problem a little bit, or they put the questions in a different order, or they change something up about it, you won't be able to fall back on that kind of pattern. You need to know what these words mean and what you're being asked to find. Question 8, if f of x equals x squared plus 3, state the domain and range. And once again, you may sketch a graph, but you do not have to. Well, for domain, I don't need to sketch anything. Domain is all real numbers because it's always all real numbers. If you want the detailed explanation of why it is all real numbers, please go back and watch the video because I went through the why behind that, but a test review really isn't the time to do that. Range, I actually want that sketch for. Okay, this one goes up 3. And so I'm going to count up 3 and put my parabola on there. There it is. Okay, and it looks something like this. Range is all of your possible y coordinates. So when I go to write my answer, I'm going to start with y. And I can tell from looking at this that the y's start right there and then they go upward. How do I know they go upward? Because the parabola is going upward. If I come down here, there's no parabola and therefore nothing in my range. So they start and stop at 3. I forgot to turn off the highlighter. And because they're going upward, it is greater than or equal to. If you are more comfortable with interval notation, you can express those answers as follows. Negative infinity to infinity, apologizing for my horrible infinity signs, or for your range, you would be starting at 3 and going to infinity, and you do need to use the bracket because the 3 is included. For numbers 9 through 11, use a highlighter or colored pen to indicate the required interval, then state the interval. So the first one is showing me, do you know what these intervals are? Can you identify them on a graph? The second question is, can you state them? So I'm going to grab my highlighter, and what I asked you to do in class was to color code it. So if you were doing increasing, then highlight the word increasing and then the corresponding piece of the graph. And then when you go to do decreasing, highlight the word decreasing and then the corresponding piece. Some of you lost points because you only did the highlighting, but you didn't tell me which was which doesn't really help me. I didn't take off all the points for that if they were split up the right way, but again, I'm missing a piece of information there. Now, for stating the interval, you really can do this either way, and you are split about 50-50 on how to do it. If you want to do interval notation, then your x coordinates, we're always looking at the x coordinates. So in this case, the increasing interval starts down there at negative infinity and stops when you get to the 1, and we do use a parenthesis there. Some people will use a bracket, like it kind of what do you want to do with a vertex, but or you could say x is less than 1. Okay, and then for decreasing picks up at that 1 and goes on to infinity, or you could see x is greater than 1. Okay, either one of those notations, I would not recommend doing both. If I figure out which one of those works better for you, and that's the one you want to use. For positive and negative, you needed to do the same thing. So you needed to indicate which interval was which. Okay, and positive and negative is not the same thing as increasing and decreasing. Then the interval for positives, I was flexible on the numbers that you used here because on the photocopy of it, the numbers really did not come out very well. And so if you picked the wrong numbers, I kind of let that slide. I think this one is like -3 to 5. So your interval might be literally -3 to 5, or you might say -3 is less than x is less than 5. And that's because there's a -3 and there's the 5, and the positive is everything in between them. And then for your negatives, okay, negatives could be at the, sorry about that. at the negative infinity, and then they stop when you get to the -3. So you might say negative infinity to 3, and then they pick up again at the 5 and then go outward to positive infinity. If you prefer interval notation for that, it would be x is less than, that's to be -3, and then x is greater than 5. And again, you remember what the words mean. Do not try to memorize something like, I'll put the parentheses here. Know why there are parentheses. Know why they're set up and arranged the way they are. That's what you need to drive at if you really want to be getting a better grade. Okay, just trying to memorize patterns. All I have to do is flip the positive negative, okay, or flip the parabola over, and it's not going to work anymore. So positive is above the x-axis, negative is below the x-axis. Increasing means it's going up from left to right. Decreasing means it's going down from left to right. All right, then we have two more of the same type. So increasing again, and then some of you changed, not what I meant to do. Let's try that again. Some of you changed the colors you were using for increasing and decreasing halfway through each problem, which made it harder, just made it harder. Increasing going up from left to right, and then decreasing is heading down from left to right. If you use your interval notation on that, sorry, that's yellow. That is not what I meant to click on. There we go. Your increasing starts at the 1 and goes to the right, which means it's going to go to infinity. Or you would say x is greater than 1. Your negative is over here, starting at negative infinity, and then it stops. That green section stops when you get to the 1. And so not that, that's wrong. This would be negative infinity and then stopping at the 1, or x is less than 1. In the next one, we have positive, which of course is above the x-axis. And sorry about the missing line there. That was an oversight. Negative is below. Okay, and that's some of the points right there. In this one, you've got your positive, and that's supposed to be an infinity, negative infinity, and infinity. So your positive starts at that negative infinity, and it stops being positive when it hits what looks like -2. So negative infinity to -2, and then it picks up again being positive over here at the 4, and then goes outward to the infinity. If you want to use interval notation, you would say x is less than -2 and the x is greater than 4. On your negative, we have that -2 and that +4 and everything in between. So -2 to +4, or in interval notation, -2 is less than x is less than 4. Don't mix the notations up, okay? Pick whichever notation you feel better about, and that's the one you're going to use. And remember that you're only ever using the x coordinates for these. So notice on the increasing, decreasing, I'm not using the y coordinate, I'm using the number 1, I'm using that x coordinate. Okay, where does the green stop? Where does the yellow start? And over here, we're using those x coordinates. Where does the green stop and the orange begin? Where does the orange stop and the green begin? And so we're using that x coordinate. You never, ever, ever looking at those y coordinates for this. Number 13 was review material. And I think I gave you in the review that we did in class, I gave you some ways that you could review do this. You could try guess and check. I mean, you could try a lot of different things, but the way I would do it is I would start by subtracting 4. So I could get that absolute value by itself. Before you can apply the definition of absolute value, you do need to get that absolute value by itself. So remember that absolute value is distance from 0. And so because you can go left or you can go right, when you're taking absolute value, it generates two different answers. I tend to do it this way. If I have the absolute value of something and that something is equal to 1, then I know that that something could be -1 or that something could be 1. And so what is my something here? My something is x minus 1. That could be -1 or 1. Solve both. -1 plus 1 is 0. And 1 plus 1, hopefully that's okay, is 2. And there are your two answers. All right, moving on. Last two problems, so this is it. If the vertex of a parabola is at 1, -2, and -2, 1 is a point on the parabola, what is another point on the parabola? And it says you may graph it, but you do not have to. What that means is that I'm not going to be grading a graph. Okay, I'm not going to look at your graph and say, oh, but they had it. So the vertex is at 1, -2. So make sure that you are plotting that correctly. That means you go 1 to the right and 2 down. And I'm going to label that V for vertex. And then one of the other points is -2, 1. And so we go left 1, 2, and then up 1. And it just says, what is another point that you know has to be on this parabola? Well, we know parabolas are symmetrical, and we know that the vertex is on that axis of symmetry. So if there is a point over here, there has to be a mirror point over here. Make sure you get the location correct. Some of you just did it too fast and you didn't really look closely at it. So let's look at it. To get to the axis of symmetry, I start here and I go 1, 2, 3 units. So 1, 2, 3, 3 spaces. And so to find the mirror point, I'm going to go 1, 2, 3, which is going to put me right there. 1, 2, 3. And the location of that point is 1, 2, 3, 4, 1. All you were graded on was whether you got the 4 or 1, not what you showed. Okay, so you may graph it, but you don't have to. And question 15. If the x-intercepts of a parabola are at -1, 0, and 5, 0, what is the axis of symmetry? And you do want to make sure you remember the correct notation. Axis of symmetry is going to start with x equals. And we have the points, the x-intercepts, are at -1, 0, and 1, 2, 3, 4, 5. And we know that parabolas are symmetrical. And so the axis of symmetry is going to run right in between them. So you might count how many spaces, 1, 2, 3, 4, 5, 6. And so half of 6 would be 3. So 1, 2, 3 is going to put me right here. Where is right here? Right here is at x equals 2. Most common mistake on that was people miscounting. And on the one right above it, there were all kinds of parabolas that weren't symmetrical. You were too close. I don't know what people did, if they didn't count the y-axis or jumped over it. I'm not totally sure what people did, but did it too fast and then had something that did not even look symmetrical, but then gave the answer anyway, rather than going back and making sure that they counted correctly. So make sure that you do check. And then some people just, again, I think maybe you're jumping over the y-axis, like it doesn't count. 0 is a number, make sure you count it. So that was the entire test. It took me less than 24 minutes to go over the entire test with a lot of explanations. So when you come to do a retake, if you come during lunch and you have 30 minutes, but you're not explaining everything, it should be very, very doable within 30 minutes. Just make sure that you are prepared to go over it and to give me your best shot on it. Let me know if you have any questions.